Alright guys, so today we're going to look at chemical reactions and their equations. So we worked on chemical formulas, looking at the formula for a molecule or a compound, identifying how many elements there were in that formula, and counting the total number of atoms there were for each element. We're going to take that a step further and now look at chemical equations. So going back though to why atoms form molecules, just to refresh our brains, we know that atoms make up a molecule, they have to be attracted to each other. And that's usually because one atom's either missing electrons or one has too many electrons. And because we want to find this balance, they're going to be attracted to those differences in charge and then try to combine to share those electrons. So we can do that with our ionic bonds, where one atom is transferring or giving its electron to another atom, or those covalent bonds where one or two atoms come together and share their electrons in pairs. So when those bonds form, those make our molecules. Those bonds can form during a chemical reaction. So remember, a chemical reaction happens where when it happens, our chemical bonds are broken and reformed to make new substances. So during a chemical reaction, we can take substances and break those bonds, rearrange them, and get something completely new. So just to revisit those signs of a chemical reaction, we can have a change in color, a release of a gas or vapor, we can have heat or light, our temperatures can change, there can be a new odor or strange odor, or there can even be a change in the state of matter, so solid, liquid, gas. So just remembering the signs that chemical reactions are taking place, telling us that there is something happening to these substances and they are changing it to something new. So we can take our formulas and put them into a chemical equation. And in a chemical equation, there are two parts to it. So we have a reactant side and a product side. So think of a chemical equation kind of like baking. Reactants would be your ingredients, what you put into the equation. Your product is your end result. So that yummy bread or delicious cookies or pizza or something that you could eat because we love food in this class. So in this example, we have 2H2 plus O2, the red. That's my reactants, what I'm putting into the equation. The arrow is telling me it's going to yield a product of 2H2O. So the yield is that chemical reaction is going to take place, and after that reaction, I get a product or an end result of 2H2O, so two water molecules. Now, an important law to remember for chemical equations is that the law of conservation of mass. So during a chemical reaction, the atoms are rearranged, but they are not created or destroyed. The mass of the products is equal to the mass of the reactants. This means that in your chemical equation, you're not going to be gaining or losing any atoms. You're not going to be getting any new elements or losing elements. You're going to have the same number of atoms and elements in the reactant, what you put in, as on in the product side. So they're just going to be rearranged in a different order. So looking at that example again, 2H2 plus O2, my reactants, giving me a product of 2H2O. This chemical equation, there's like a little image here. On the reactant side, so the left side, I have four circles that are white. That represents my four hydrogen atoms. And two circles that are red, those are my two oxygen atoms. This is what I'm putting in. The arrow over to the right side is what I'm getting out, those two water molecules. Oh my goodness, water molecules. So 2H2O. If you count though, even though they're arranged differently, I still have two oxygen atoms, the red circles, and four hydrogen atoms, the white circles. They're just arranged differently. So I didn't gain or lose any atoms, and I didn't get any new elements in this chemical reaction. They're exactly the same. Chemical formulas. So remember, in a chemical formula, we use coefficients and subscripts to help us count how many atoms and molecules there are in that formula. So we're going to take what we learned on how to count our atoms from our formula and apply that to our chemical equation to see if the equation is balanced or not. Because according to that law of conservation of mass, we don't want to have a different number of atoms or new elements in our equation. There should be the same number of atoms on each side of the equation, the reactant side and the product side. So going back to that equation, 2H2 plus O2 yielding a product of 2H2O. If you were to count your atoms out using our skills for counting atoms with our chemical formulas, looking at my reactant side, I have 4H, so I have that subscript 2 here, that gives me 2 hydrogen. I have a coefficient 2, that gives me 2 times 2, that's 4, so that's how I got 4. I have 2 oxygen, a subscript 2 tells me there's 2 oxygen atoms, no coefficient. So this is my reactant side. I'm going to look at now, I'm going to keep that here, give me a total of 6. So that side is done. I'm going to do the same thing to the product side. So counting my atoms with this formula. I pull out my elements, H and O. I have a subscript 2 here, telling me there's 2 hydrogen atoms. I have a coefficient though, so I have to apply that. So 2 times 2 is 4, giving me 4 hydrogen. I have no subscript here, but a coefficient in front of the O, or the oxygen. So that's telling me there's 2 oxygen. And then if I look, I have 4 here, 4 here. So these match. My 2 here and 2 here for oxygen, those match. And my total matches. So I didn't gain or lose any atoms, and my elements are still the same, even though the formulas that represent them are different. So that is a balanced equation. So let's see if you can figure out if this chemical equation is balanced. I have K plus O2, that's my reactant, giving me a product of K2O. So take a moment here, press pause, and then see if you can count the atoms for the formula on the reactant side. So pull out your elements, count your atoms, give me a total. Do the same exact thing for the product side. Pull out your elements, count the atoms, give me a total, and then tell me if this equation is balanced or not. So checking our equation, K plus O2, giving me a product of K2O. Counting our atoms on the reactant side, you should have gotten 1 K, or potassium, and 2 O, or oxygen, giving you a total of 3. Now, we're going to check our product side. You should have gotten 2 K and 1 O, giving you a total of 3. Now, this is an unbalanced equation. And this is unbalanced because even though my totals here are the same for my product and reactant side, the number of atoms for the elements are not the same. So I have, for my K, or potassium, my reactants I had 1, and my product I ended with 2. My oxygen, in my reactants I had 2, in my products I had 1. So I am both gaining some potassium atoms and losing some oxygen atoms. And because of that law of conservation of mass, that shouldn't happen. So this is an unbalanced equation. So for your homework, you're going to practice with these 2 equations. You're going to use your atom counting skills to identify if problems 1 and 2 are balanced or unbalanced. And then I need you to identify which side of the equation is the reactant side and which side is the product side. And then after our warm-ups tomorrow, we're going to go over these 2 questions to see which one is balanced or unbalanced, and how well you did it. And if you have any questions, feel free to shoot me an email and I'll try my best to help you before we go over it in class.